So AFC, available fault current and short circuit current ratings, specifically HVAC equipment. So this is one I will say at least once a month, if not more than once a month, we get a question on this in the CQD and just from contractors in general. And it's usually in some kind of a frustration or panic because they've got an installation that may not have been their choice, but they've got to deal with it, right?
Yep.
So the most common question that I get is related to HVAC equipment and projects up against certificate occupancy. So there are inspectors coming through doing final. We've got new rules in the NEC, and relatively new rules, depending on where you're at, that HVAC equipment, the controls have to be marked with the available fault current and the short circuit current rating. And what ends up happening is once we get down to that final inspection time, it's identified that the HVAC electrical equipment is only rated for 5,000 amps of fault current.
Yep.
And there is above and beyond that available at each one of those connections. Specifically, especially if it's a larger HVAC that we're sure it's got like a, 100, 200, 300 amp feet or something like that. You're seeing fault currents in 7,000, 8,000 amps. And now the electrical contractor's on the hook for a violation that they don't really even know about because they didn't specify the HVAC equipment.
Yep.
So this one comes in a lot.
It does.
There's a lot of different moving pieces here from an NEC standpoint.
So whenever I get those questions, the first step, because I see a lot of people confuse short circuit current ratings and interrupting ratings of circuit breakers and fuses, right? So in fact, I did a video that my example to this video, I'll try to throw the QR code up for it as well, or a link. I use the example of a weightlifter on a bench pressing. And I say, okay, you see a weightlifter on a bench and you see the weights. And then I ask everybody, what's the other person in the picture? And they'll say, well, the spotter. So you're right. So I'll go, what if I told you that I can bench press 300 pounds when spotted by Lou Ferrigno? Okay. Because when the spotter's job is to make sure that the equipment, the weightlifter, doesn't get hurt. Well, the overcurrent protective devices work together with the equipment to make sure that the equipment really doesn't say you have equipment that's 200,000 amp rated or 5,000 amp rated. If you have an overcurrent device in front of it, that equipment never really sees that amount of fault current, because the overcurrent device, if you know current limitation, will reduce the peak and the amount of time. So the damage is reduced. So they work together. And when you look at equipment, you got to make sure that if you buy, say, a fusible disconnect or a non-fusible disconnect, this is the big one. I see this one.
Probably more common.
Right? Oh, yeah. They'll buy a non-fusible disconnect and they'll say, look, it's got a 200,000 amp short circuit current rating. And then I go, well, you have to read the rest of the sentence. When protected by this specific device. Yeah. So then you say, okay, now you have to pick the right overcurrent device ahead of it or make it integral with it. And then when you get to transfer switches, it's even worse, right? Because now they give you this huge recipe. So short circuit current rating is the ability of the product to withstand current passing through it. And interrupting rating is the ability of the overcurrent device to stop the flow of current. So SCCR doesn't change just because you have a high interrupting rating overcurrent device. If I put a fuse, I have people do this. They'll say, well, I have a fuse as the main, it's 200,000. So I've automatically got a 200,000 amp short circuit current rating. And you don't. You go, well, what is the power distribution block? What are, all those different components? If there's a starter in there, do you have the right fuse ahead of it? If you put a breaker, you can get it done with a breaker. If you put a breaker there, do you have the right circuit breaker? You got to have the right combinations to make sure that you have the right short circuit current rating. So the first step, you got to understand what SCCR is, and then you've got to sit down and answer all those challenges. And you take a look at that project. You said HVAC, right? HVAC is typically selected by the mechanical guy or gal, right?
Yeah. And they're typically going to go for whatever is the most economical, right?
That's absolutely right. The other one that I see a lot of are elevator control panels.
Yeah.
And where I see it the most, I would get calls from Seattle, Washington, New York City, Pittsburgh, Houston, those big cities with secondary networks. You got like 200,000 amps at the base of the building, and then you run busway. I call busway high efficient fault delivering system. That's from NEC,
right?
So you have a lot of fault current at the top of that building. You could have 50,000 amps, 40,000 amps, and then you've got a 5K elevator control panel. And you say, well, now what am I going to do? So, which we're going to get into. In my opinion, you've got two scenarios. One is a new installation, and there's no excuses.
No.
Right?
No. I mean, because let's be real. If we take this to the very, very, strip it down to the most basic concept, where all of our requirements start for interrupting rating and short circuit current rating is sections 110.9 and 110.10 general requirements, right? 110.9 tells us we have to use properly rated overcurrent protection devices for the specific available fault current with the proper interrupting rating.
Right.
And then 110.10 says our equipment has to be short circuit current rated for what it's going to be exposed to. Yep. Another token Dan NEC term that I love to use in my trainings is the rapid disassembly, right?
Oh yeah,
if you have equipment that's not properly rated, you are going to experience rapid disassembly of that equipment.
Absolutely. I always call it the unintended rapid disassembly in the field.
In the field, yeah.
Not in the lab. It's in the field.
So if we look at those two requirements, it really drives the idea that there should be on a new installation, there should be documentation somewhere. Sure. That, a short circuit current study or an evaluation of some sort that is on file that the HJ should have, access to. Absolutely. The electrical contractor should have access to, and confirm these things ahead of time.
Yeah. Now, the challenge that we have, when you think about when you're calculating fault currents, we don't calculate it down to a receptacle. We calculate it down to your main distribution equipment, your panel boards. Industrial control panels are even further down the line. And I don't know. I can tell you honestly, I have never done a short circuit study that went down to an industrial control panel or to the elevator control panel or things like that. I hit all of the major distribution, right? So arguably I could say, when we say, well, I didn't have enough information. Well, you got to a point, and in many cases, you don't have to go all the ways down to the equipment. Because if my equipment is 10K, I buy a panel board and it's the lowest short circuit current rating and interrupting rating of current devices, say 10,000 amps. Well, I only have to calculate as far down as just below 10,000 amps because any length of conductor I put down closer to that panel board, I know the fault current is going to be much less. So in many cases on the secondary of a transformer, I stop at the secondary of a transformer because when I get there,
it should be less than 10K.
It's going to be less, as long as, it depends on the size of the transformer and the impedance, whatnot. So you've got to understand the recipe that you're going for, and then understand I have to do this calculation down to that equipment, but not necessarily down to it. At least when I get to a low enough number, then I say, okay, I'm done.
Right.
Right. But that's another part of the challenges that we have is, do I have enough data from what the engineer or the qualified person did when they calculated that fault current, and then work your way back down. So that, and now on a new installation, it's because you have the design phase. So you're going to have to specify, this is the hard part. You've got to estimate what you think the available fault current is going to be. And you're probably going to have to estimate a little high so that if things change, because transformer impedances could come in differently. Your electrician may say, I took that conductor run wasn't 100 feet, it was 50 feet, right? So until you get your as-built. So you're going to have to, and I call that moxie, right? So it's just a matter of what your experience is to say, okay, I feel comfortable with this rating. And then you do your as-built drawings and make sure you've bought the right equipment. Because to your point, I mean, it gets down to the discussion of whenever we get that phone call, it's not because they're in the design phase and they're not sure what to buy.
Right.
It's typically, I am out at a job site. I calculated the fault current. That equipment's 5K. I've got 10K. What do I do?
Well, and that you just brought up what I feel like is probably one of the most key issues here. In the electrical industry, we've always had this 10K threshold in our mind for short circuit current ratings or interrupting ratings. Overcurrent device, if it's not marked, what is the rating?
Yeah.
Right. It's 10K. So now you throw these control panels for HVAC equipment or elevator controls or even industrial control panels where they have a 5K rating. We have to kind of rethink that whole concept of as soon as we get to 10K, we're done, because it's not going to be adequate anymore.
Well, GFCI receptacle. I got burned one time on a GFCI. We had a project where we had a GFCI in a switchboard. Okay. Good inspector. He opens up the door. He sees the GFCI. He knows he's got 8,000 amps available fault current. So he says, that GFCI is over duty. So I got a call from the field and they were like, this inspector is rejecting because the GFCI that's in the equipment. I'm like, I never heard of an SCCR on a GFCI. So then I looked it up and sure enough, everything,
conductors, devices, everything, anything that is going to have current going through it is going to have a short circuit current.
I was absolutely amazed in that. And it was 2,000 amps with just out of the box. And then if you could buy a 10,000 amp device with a short circuit current rating. And then I started looking at different manufacturers and I'm looking at all the literature, and sure enough, you can buy a 10K. Some of them, they sell, they're all 10K, but you buy the wrong one and you're going to have to replace it. So I had to buy one, and then I bought an extra one for the desk because it was a teaching moment. Because the moment I learned something, I like to share it,
Yeah, because if you don't know, I'd think of how many other people.
Well, that's exactly right. That's exactly right. So, but yes, and then the UL 508, the UL 508A, the standard for industrial control panels, has a table in there of the default short circuit current ratings of various pieces of equipment that you'll find in an industrial control panel. The problem I have with that table is they call it a short circuit current rating, but yet they have for a circuit breaker that's not labeled, it's 5K. For a fuse, it's 10K. Well, fuses and breakers don't have a short circuit current rating.
They have interrupters.
So I have to bring that up to guys like Robert Osborne and the other guys at UL just to dig them in, a little bit. But and Dan Easer, he's on 508. But okay, so now you had mentioned in the answer to this question about collaboration.
Oh yeah, collaboration. That's the one that as soon as I see the acronym HVAC in a question, I know that the road we're going down. You got to ask the questions. If you're the one designing these systems, if you're going to be the contractor installing these systems, or both, is design build, which is a lot of times the case.
Yeah.
You have to ask the questions. You have to get with the GC, the mechanical contractor, and find out, hey, I need the specs on the HVAC equipment that you're installing, so you can confer ahead of time and not be caught in a situation where now you're trying to get a certificate of occupancy and you've got 3 HVAC pieces of rooftop units that are not properly rated for what they're going to be exposed to. Like if it's an industrial control panel that you built in accordance with Article 409 of the NEC, you don't have that listing element to work around, right?
Sure.
But if it's a part of an elevator control system,
absolutely,
or piece of HVAC equipment, you start taking things out and replacing things and you might find yourself into a whole other world of hurt that you don't want to be involved in.
You're exactly, but what I learned in that process. So I'm looking at that diagram and I'm looking at all the components. I'm like, well, shoot, they can take this to 65K pretty easy. So I told them, I said, call the manufacturer and then ask them if they have the ability to make these modifications in the field, or what. Well, I went right down the road of making the modifications in the field, because then you need a field evaluation, all that other good stuff. But what I learned was that specific manufacturer, and they probably others do it, they were like, well, we have a different panel. What we can do is ship the new panel. You take that one off, put this one on. They give you instructions, and then you get a field evaluation from a nationally recognized testing laboratory, and they were able to bring that HVAC unit right up to speed. The problem I have on the elevator side is I don't have that option because they don't make those elevator control panels with it.
And you bring up a couple of good points there, right? So the ability to work with a manufacturer and potentially get something field evaluated is an option that's there. Absolutely. Those come at a cost, right? There's definitely a cost in that fix, but if that's the only option, then that's the one you go with, and not even the only option, but that's definitely a tool in your toolbox. The elevator control panel is an interesting one, and that is one I get far less questions about.
You know why I think?
I'm going to give you my reason why I think.
Yeah.
And because one, electrical contractors and electrical inspectors are not allowed in the elevator control rooms.
Exactly.
It is that is an area that is off limits for anybody but elevator mechanics and elevator inspectors.
Yep.
And elevator inspectors, you want to talk about multi-hat. When I was in AHJ in the city of Milwaukee, we were teamed up with the elevator inspector groups. And those individuals, they have, we talk about our different codes that we have to deal with. They have those and then some.
Yeah.
And they're very territorial of their elevator control area. So for an electrician to get in there or an electrical inspector to get in there and verify that stuff, you're pretty much taking the elevator inspector's word for it and the electrical contractor's word for it at that point, because it's hard. There are times where I couldn't even get in there to verify that the GFCI that was installed for the sump in the elevator pit was correct, there.
Yeah.
And the elevator inspector say, nope, that's our territory. We'll verify it. We'll make sure it's done.
Wow.
So yeah, that's my thought process as to why that's something that might not be is commonly enforced or occurring.
I agree with you 100%. And the other problem that you have on the design side, on the mechanical. So whenever I go to architectural, like when I worked for Gilbert, we had our mechanical people and our electrical people sitting right next to each other. Okay. Neither of them pick and specify the elevator. The architect does. And the architect doesn't sit next to the mechanical guy nor the electrical guy. So you have a greater chance of having the right people looking and commingling and collaborating with each other in the design phase than you have with an elevator.
So what are some other solutions that are out there? Maybe that short of having the equipment field evaluated and rebuilt, what are some other solutions out there?
One thing you could do, tell me,
not to put you on the spot.
No, I got two things. The only thing, put it this way. If I'm not going to change the equipment, if I have a piece of equipment that has 5,000 amp short circuit current rating and I've got 10,000 amps, if I'm not going to change the equipment, then I need to lower the fault current. So I either tell my electrician to take a few laps around the block with the conductor to lower the fault current, because conductor length will lower the fault current just because of the impedance, or I can put a 1-to-1 transformer. Now, a 1-to-1 transformer, which is what I've seen on elevator control panels. In fact, there's a catalog number. One of the manufacturers actually has a catalog number to buy a 1-to-1 transformer. And then I got the call from the design engineer who says, well, now that I have a transformer on the roof, A, I have to find space for it. B, I'm in Article 450. I need to have primary and secondary protection if it's a delta Y ground transformer, which it probably is.
Yeah,
you're going to need at least if you go with primary only protection, then you've got to look at what piece of equipment you're supplying. If it's a panel board, then you're going to need secondary protection on the secondary of the transformer. That primary overcurrent device does not provide protection to the secondary conductors nor the secondary equipment, right? So you'd have to follow the right rules. So it gets a little more complicated. It definitely gets more expensive.
So what about, I know our friends over at Bussman have some solutions as well with including fuse options and installing a fuse disconnect in series with another overcurrent device potentially.
You could potentially do that. Now you're into the world of probably series ratings and things like that. And I have a fundamental.
This is the engineer. I can feel the engineer. The mind of the engineer coming out, Tom.
I'll tell you what happened. I had an individual call me about an issue with a machinery. It wasn't an industrial control panel. It was an old piece of machinery. You weren't going to modify the control circuit for it because it was vintage, right? And it was one of these products that you see in a manufacturing facility where you just say, I got to live with this piece of machinery and hopefully it never breaks because you're making your own parts for it. So his issue was the fault current was way higher. So I had gone down the road of putting a fusible disconnect right in front of it. And what I did was I calculated the incident energy at that equipment. And it was like 0.3 or something, right? So if I was going to work on that equipment and have a fault in that equipment downstream of a fuse doing justified energized work, if I had a fault, I'm in gloves, glasses. If I followed the rules of 70E with that low of the arc flash boundary was
less than the working distance. Right?
Yeah, exactly. So it was really short. So I could get away with a pair of gloves. So my thought process was, and what I told him, I said, look, because of the equipment, you can't change it. You're either going to have to put a 1-to-1 transformer out in front of it, lower that fault current temporarily, because he had the equipment down at the time and he wanted to re-energize it. I said, you could put a fusible disconnect in front of it that lets you, that increases the likelihood you're going to establish an electrically safe work condition. So anybody who's going to work on it, they can reach over, pull the handle, lock and tag it out, okay? And if there's a problem in it, the incident energy is going to be very low. Does it still violate 110.10? Absolutely. But we all live in this management of risk world.
Yeah.
Likelihood and severity. If I can control the likelihood of you establishing an electrically safe work condition, and then the severity, should you be measuring something in that piece of equipment, then from an arc flash perspective, then I feel good. The only thing you don't have in that is the shock hazard control. I said, so minus taking the time, which they put it on the agenda for the budget, right? Because, we all live on budgets. He says, minus putting a 1-to-1 transformer in front of it to knock it down, they put a fusible disconnect in front of it and then planned to put that transformer. Because I said, you're going to need secondary protection anyway, right? I said, so you're not wasting money by buying a fusible disconnect that you can put multiple different types of fuses in front of it. So it is an option. You got to be very careful, in my opinion, when you start going down the road of trying to, if it's not straight from a table of series ratings, now you're getting in the world of 508A.
Right.
You really got to know what you're doing. You can get a qualified person to help you with that and say, based upon the rules of 508A, we can address the short circuit current.
And there's absolutely, there's a lot of resources out there from busmen and other manufacturers that provide that information, and even have people on staff that will walk you through that process, and they're aware of these situations when they come up, right? It's something that is industry wide and is one of those things that continually is an issue, and until we get it figured out. But you touched on another thing in your discussion, and that's incident energy. The safety element that available fault current plays in the world of electrical equipment, right? And it just proves even further into that point. We've got all these requirements from an electrical safety standpoint. We've got NEC requirements that say the equipment's got to be rated properly. There really is no excuse anymore that this information is not available.
Oh, that's exactly right. Yeah.
If you don't know the available fault current or the short circuit current ratings of the equipment, there's multiple levels that the system is being failed on, right?
Absolutely.
Because it's safety, it's the NEC, it's other design elements. It could be selective coordination that's involved. There's all kinds of different facets that these calculations should be made at some point.
You got Article 408 that tells you every panel board, switchboard, and switchgear has to be labeled with an available fault current. 2026 code is going down the road of saying you have to have arc flash labels on your equipment. We have, from a short circuit current rating, you've got 110.10. I could make the argument you don't need any other reference to short circuit current ratings anywhere in the code because it's in 110. Yet we've got it in 409.22, 440.b for air conditioning, 409 for industrial control panels, 670 for industrial machinery, 705 and 707.08 for the transfer switches. So you've got 710 for interconnected or standalone systems. That article's gone by and by, but it depends on what edition you're on. But there are so many places in the National Electrical Code where we have this reference because people keep missing it.
Well, and I think it comes back to the idea of, there used to, in my experience, there used to be this misnomer out there that as long as the service equipment was rated properly for the incoming fault current from the utility and the service disconnect was rated properly, like magically the available fault current just disappeared after the service disconnect and all was good. So it is seriously feels like it's been a 15-year effort in trying to retrain not just installers, contractors, engineers, but also AHJs. And that, look, fault current is an animal that you have to deal with throughout the entire system.
That's exactly right.
And by putting it front and center with these additional labeling requirements at different key pieces of equipment where we see the most common failures or the most common issues with compatibility with having high fault currents, I think it's going to help educate the industry in
absolutely. The most blatant with the time that it was like somebody can just come up and slap you in the face with it. I did a presentation. There were 3 people in the audience, only 3. I traveled. I was doing the round robin in one of our states. And I had 3 people, and I was talking about short circuit current ratings, calculating available fault current, and I explained, just like you said, you calculate the fault current from the utility at the service, and then you do it at all these different panel boards, and you do the comparison. And a gentleman from he was responsible for the electrical distribution on a very large commercial application. And he said exactly what you just said. I thought that because he had a fuse at the main, it was 200,000 amp interrupting rating. He thought that because of that fuse, everything else was fine.
Yeah.
And I was like, wow, no. And it was an eye opener for him. And then we ended up doing a study for his facility and identifying all of those components that were over-dutyed. And then we had a plan in place to address it. But that's the other thing. You can install it, voltage same way.
Yeah.
I've had people ask me, they say, can I install a circuit breaker, a 120 volt circuit breaker on a 240 volt application? I'm like, well, you can, but just don't let it open, right? So if you put it in that place, if you put a 5,000 amp interrupting rating or a 10K interrupting rating overcurrent device, it will supply power. But the first opportunity that you actually have a call to action to do something, that's when the unintended rapid disassembly in the field is going to occur. So, all right.
Yeah, just because it works doesn't mean it's safe, right?
That's exactly right. They'll say, well, the power's on. Yeah, the power's on. And hopefully nothing tells that breaker to open or that fuse to open, because when it does, get your party hat on, because it's going to be a show.
So do you think I think the short circuit current rating?
I think we have
topic to death.
I think we have.
If you guys have any other questions related to short circuit current or available fault current interrupting ratings, by all means, submit another question. And I think the goal is we'll get a few of these episodes out, and then maybe we'll do a live event one where people can comment and we can take some questions.
I just got goosebumps. I love it. All right. That's short circuit current ratings. And now we're going to move to the next one.